let's solve this second order linear differential equation with initial values. The first thing we'll do is integrate to y prime, integrating both sides. So the integral of the left side is the integral of y double prime, which results in y prime. And so now we have to go through the mechanics of integrating the right-hand side. Well, we've got some exponential functions here, and the integral of an exponential is itself divided by the derivative of the exponent. So same idea here. We're going to have to divide by -3. And then plus some constant of integration. Okay, so now we can calculate the value of that constant of integration with our initial value right here. So we know that y prime is equal to 2 when we plug in x equals 0. So e to the 0 is 1, so we're going to end up with 12. So I simplified that fraction right there. When we plug in 0 here, once again we have e to the 0, which is 1. So we're going to have plus 6 and then plus c. So that tells us that this constant of integration is -16. So therefore y, if we integrate both sides again, the integral of y prime is y. We're going to have the integral of, let's simplify that. So we have 12 e to the 4x plus 6 e to the minus 3x plus, minus 16 dx. So we integrate here, we have an exponential. The integral of an exponential is itself divided by the derivative of the exponent. Again here, integral of an exponential is itself divided by the derivative of the exponent. The integral of -16 is -16x, and then we have a constant of integration, which is a different c than the c above, but we will solve for this c also. This c is solved. Y of 0 is 3, so y is equal to 3 when we plug in 0 for x. So we're going to plug in 0 in all these places. And when we plug in 0 for the exponential, e to the 0 is 1, so we get 12 divided by 4, which is 3. In the second term, e to the 0 once again is 1, so we get 6 divided by -3, which is -2. And then -16 times 0, and then plus c, and so we are going to get that this c is equal to 2. So therefore, our function that satisfies this, our specific function, 12 divided by 4 is 3. Our specific function will be this function. So that is the particular antiderivative, if you will, that satisfies these two initial values.